to bring our ideas and keep be open. Ask. You can stop me in between if you don't understand. This is now our project. We need to understand it very, very clearly. We need to understand it very, very clearly. And if I told, for example, if I told if I told you were doubting that I can't follow this, that I can't report you to the SAR, or that I cannot be able to disown you as part of the meeting, I say that try me, but we don't have to do that. We want to what our goal is to make sure that, guys, let's make this even memorable, that oh, that was a great team, that was a good team, we did well and everything, networking, in gaining skills, in learning from each other, and also in knowing how to work as a team. So let this be memorable and let this be enjoyable. Ngati tambo shupana shupana tizaona munga tivutana tishita bwanji, but kamboenda chape mushe we'll be in harmony, guys. So that is the goal. That is the goal. We'll be in harmony. Now, this is the project at hand. Now, I want us to imagine this. Uh, in this team, we have got guys from software engineering and others from networking. So what I wanted initially, I wanted 3 guys from software and 3 guys from networking, but vanabo vafuta kovena ngwa ku networking, it's like monga mu group mwa supervisor mwatu ni wang'ono wa networking. Ivamene tinapesekana veve. So we have got 2 guys in networking, 2 guys in software. Why do we have 2 different majors? It's the nature of the project that we have. It needs networking guys and it needs software guys. And this is one of the projects that is sort of hard to collaborate when it comes to networking guys and software guys, in that usually ava vamamveka monga sivangachai collaborate mumaimveraka monga va software na va networking monga sivangachai collaborate, but there is a possibility of collaboration in many places. So we want to imagine this. We want to imagine that it's a company. Imagine that it's a company that hired networking engineers. So I want you to listen to this clearly. Imagine that it's a company that hired networking engineers that built a network, which is, in our case, let's imagine the company hired Daniel Nkoma and also Joshua Chipeta. Let's imagine that the company hired Daniel and Joshua. Now, these guys, they built a network. Now, after they built the entire network for that company, they configured everything that is required. They put up firewalls. They make sure that the security is good and everything. Now, after these guys built a network, the same company, now let's imagine that it has been too much for them to manually, all the time, to manually check devices on the network that are down, or to manually check devices on the network that are stalling, or that have got bad latency, or that are utilizing too much CPU power. Now, the company says that we are also spending too much money on hiring a lot of networking guys managing the network. So we need a network monitoring system that will limit the number of networking guys that we are hiring, and also that will be able to give us intelligent data when it comes to all devices on the network. So the company now hires what? Software engineers, which is Christopher Banda, myself, and also Lucky. Now, where has Lucky gone? Donald, where has Donald gone? This is the and where the critical part is gone. We need to be able to understand this. Let me just give him a call. Just bear with me for a little bit.
All right.
I don't know if it is his network or maybe it's his data or something. Okay, he's back. Wonderful. I was about to call you, brother man. Okay, so we proceed. Donald, you are available, yeah?
Yes, I am. My network just tripped.
Okay. Well, we presumed. Okay, so this is we want to describe the problem of this, the problem that this project is going to solve and everything. So we are saying that imagine that we have got there is a company. Let's imagine there is a company. Okay, let's just say an let's just say that a airport. Let's say airport. Let's say Zambia Shan Airport. So at the airport, they hire networking engineers whom they say that build the network for us. Now, in this case, it is Daniel Nkoma and Joshua. These guys, they have been hired by the airport to build a network. Now, they have built a network, they have put up firewalls, they have put up good security, they have configured everything, and everything is going good. They have tested the latency, the speed of the network is good, and everything is okay. Now, it happens that the network is so huge, it's so big that they need to hire a lot of networking guys in one department to be able to manage this network, to monitor devices, to see and test all devices, how speed they are, to see their resource utilization, how much resources they are utilizing. Now, that company looks at the number of people that they are hiring to manage that network and to monitor that network. So that company now says that let's hire software engineers to build for us a system that will be monitoring our network. What it will be doing is that it will be monitoring the network, what devices are up and what devices are down on the network, ping all devices and see how much speed how much speed the network is going at, the latency, and also how much resources each device on the network is using when it comes to CPU, memory, and the like. So they hire Christopher Banda, Donald, and me as software engineers to build the network. That is how it is. So we are going to simulate all that in this project. All of it, we are going to simulate it. We'll say that there is a company, they want this network, these are the requirements of the network and everything. Now, Daniel Nkoma and Joshua, they are going to build the network, all of it from the ground up. They'll build it industry grade network such that when you share it with any company, if it is an airport network, you share it, they can definitely use it. They are going to build that. Now, Christopher Banda, Donald, and myself, we are going to build a software that will be monitoring that network in real time. So, how we are going to work is this: I'm going to be in the middle, I'll be on the network, I'll be with the networking guys creating the network, and I'll also be with the software guys creating the software so that we link everything together. Let me just put my phone, my laptop, the charger. So I'll be on the middle. So before we proceed, any questions so far?
And no question on my end.
Okay, that's wonderful. Any question, Daniel?
No question.
Okay,
Everything is clear and on good track.
okay, wonderful. That's great. I believe no question from Joshua and no question from Donald. So let's go over this document. I'm going to share it. So what we are building is a network monitoring system. Okay, network monitoring system. So a software system that is used in network operations center in Network Operations Center. Now, for the software guys, software the software guys, you are trained to build any type of system in whichever environment you are placed. You are required to be able to build the system. Let's say you have been told to build a system for accountancy. You have to be able to research and do that and know accounting formulas and all those. So you are expected to do the same when it comes to networking. If you don't know networking, let's research and because we are applying our software skills here, where depending in with the environment where you are placed in, you are able to build the system. So we'll be able to also do that. So the system, a system that is used in a network operation center. So a network operation center is just, let's say, let's think of it like a department in a company where networks are managed, configured, and everything. It is an operation center. So now the systems that they are using to monitor the network is a NOC, is a NMS, a network monitoring system. So a system used in a NOC, network operation center. So this is the goal. Let's assume this is the goal of this company: design and implementation of real-time network monitoring and fault detection system for enterprise and ISP networks. This is the goal of this company. Now we are assuming that the network is created already, but we are going to build the network from scratch, as I have already said. So now they want us to design and implement a real-time network monitoring and fault detection system for enterprise and ISP networks. The result, the result at the end of this entire project, the result is this: this project shall implement a network monitoring system that is deployed as part of a simulated network operations center. So we are going to simulate a network operations center. The NMS platform performs real-time monitoring and fault detection, while the NOC, the Network Operations Center, represents the operational environment where alerts are analyzed and acted upon. Okay. Now, these are the core requirements that we have, the core requirements. Now, the software guys, we are going to sit down and also plan more on these requirements and draw UML diagrams and everything. We are going to apply all our software skills to these requirements. Now, these are only the core requirements that are there. Number one, device and link monitoring. The company wants device and link monitoring. So the system needs to be able to ping devices every X number of seconds. So let's say ping device every 1 second or every 2 seconds to see if those devices are still on the network and they're still up. Now, it needs also to be able to do SNMP polling, which includes CPU usage, how much each device is using CPU, memory usage, and interface status, whether it is up or it is down, the interface. Those places where the ports where we put the the whatever links that we are using, if it's Ethernet cables or what. So we see if those interfaces are up or whether they are down. Then service checks such as HTTP or SSH. So it's able, this device and link monitoring part must be able to show what ports are open for each device. What ports are open for each device. It needs to be able to show on the dashboard. Now, so the entire requirement in one line: the system continuously monitors real network devices using industry protocols. All these protocols, SNMP, HTTP, SSH, all these will be able to be monitoring. Number two requirement is that fault detection engine. We need to be able to build the engine for fault detection. This is considered just like a backend that has got rules. Now, these are the rules so far that have been defined. We are going to be able to plan all this clearly. And the networking guys, we're also going to plan the entire network, modeling it and building it, configuring and all those. Now, these rules consider it, for example, let's say a device unreachable. Let's say the system has done 3 checks and now that device is not responding. So we'll call it critical. The device is down. We call it critical. Now let's say interface down, then we'll call this as major. The security is major because the interface is down. The device is up, but the interface is down. You can't be able to ping the device. Latency, let's say 200, 200 per second latency. The network is moving at 200 per second. So then we are able to say this is a warning because it's slow. The network is slow. 200. Let's say this is okay. We are going to say 200 bits per second or 200 MBs per second. We are going to see how we are going to define these rules. Then we take it as a warning that the network is going down. Now packet loss, if the number of packets on a network that have been lost they exceed 10%, then we are going to take this as a warning because this is just too much. We can't lose 10 packets in more like every ping. In every ping we are losing 2 packets. We can assume that there is a man in the middle that is that is interfering with the packet distribution from one end to the other. So we are going to take this as a warning. Now also CPU, if the CPU exceeds 80% for 5 minutes, then this is too much. What device can use 80% of CPU in 5 minutes and not releasing CPU power? Then this has to be a warning. So we are going to also build that engine on the back end that gets the that detects all those faults, and then we were able to show all those to the dashboard. Now an alert system. So alerts include device name, IP address, fault type. So think of it more like an alert. If the severity is critical or major, we alert, and then the alert should include device name, IP address, fault type, whether it is packet loss, latency, interface down, or whether it is CPU usage, or whether it is device unreachable. And then timestamp. At what time did that thing occur? Did that event occur? Or yeah, whatever we'll be able to call it. Now, the channels of alert, we can either use email or we can use dashboard, but I recommend we use dashboard alarm sound. Then another requirement is NOC dashboard, a dashboard for this operation center, network operation center. So UI that feel like work software, not like a school app, okay? Because we want to build this a standard grade. If you're on LinkedIn, I have also shared the LinkedIn Nesnafusa Basa. If we can be able to share this on LinkedIn and everything, I want to build a proven trackable record of this entire project on LinkedIn. I've even shared everything on LinkedIn and the like. So we want to build this as an industry grade thing that we is trackable. So to be a real work software that the company can be able to use, not just a school app. Now, on this dashboard, the pages that could be there, an overview showing total devices, devices that are up and devices that are down, active alarms, then devices show the status, CPU, memory, last check time, and then topology view, just showing the topology of the network, which the networking guys we are going to build, showing the routers, the links, red links when they are down. When a device is down, the link needs to turn to red, all those. Now the incidents, the history table, this just shows the incidents that happened, the history, which devices were down and everything. And also a report. We are going to have a report. We are also going, the other requirement is network topology. This is just, let's say, on the dashboard, they are able to show the topology of the entire network. This topology can be in JSON, depending on how we are getting the information. And it's going to be live caroling and also link down turns to red. So software guys, let's put all this in mind. These are the core requirements that this company needs. Now, this is the architecture that we are going to use. Let me just zoom in. This there. Okay. So, any question before we move on? Any question, guys?
No question.
Okay. So this is the architecture that we are going to use. Now, all this is not final because there will be contributions and the like during the meetings and everything. Things will be changing. We'll be using agility type of approach when we are building. So the architecture of this, let's understand this, guys, and especially the networking guys. Let's understand this. This is critical. Let's understand how everything will be moving. So you have a Windows computer. You have got a Windows computer. This is the host computer, the local physical hardware. This whole box, this entire box, consider it as a Windows computer. Now, in this Windows computer, this is the architecture and the devices that we'll be using and everything. Now, on this Windows computer, we are going to install GNS3. GNS3 client, we install it on a Windows computer. GNS3 client. Check out GNS3. This is GNS3. Check it out. It's consider it more like Packet Tracer but advanced. It does what Packet Tracer can't do. It does real-time network building and also simulation. Packet Tracer is more like just for practice and everything, but GNS3 is industry standard. And then from Packet Tracer, from GNS3. So this is GNS3, the one that I'm showing. It's for networking guys. You need this. You'll be able to require this GNS3 guys. So you'll be able to require this. So consider that as also a requirement. Now in the same, let me just look for my document. Okay, so we have got Windows computer. On Windows computer, we install GNS3 client. This manages and views network topology. This is the use, manages and views network topology. It will communicate with a VM. This is a VM. This box is a VM. This one is a VM here. This one is a VM. So we have got in Windows, we install two things. We install GNS3 client, we install VM. Now the VM that we are going to use is VM Workstation Pro, not VirtualBox. VirtualBox is not good for this requirement. So we are going to use so this is GNS3 starting. We are going to use VM Workstation Pro. I hope you guys are writing, but I'm going to share the document. So we are going to use VM Workstation Pro. Now inside VM Workstation Pro, inside this virtual machine, we are going to have GNS3 VM. This one here, we have GNS3 nearby, right? Could GNS3 client installed directly on Windows, and we have GNS3 VM installed inside a VM, inside the virtual machine. The type of virtual machine we are going to use, VM Workstation Pro. Now GNS3 VM installed there. This GNS3 is the one that will be running this network that we are going to build, the simulated network. It is the one that we are going to use. GNS3 client used for topology and creating the network. GNS3 VM used for running this network. Now this network will communicate with the Ubuntu server. So inside VM Workstation Pro, we are also going to install Ubuntu, the Ubuntu server. We are going to install the Ubuntu server. Now this is the part where the software guys need to understand this part here. Inside, we are going to have Ubuntu. Now, Ubuntu server, this is where our monitoring engine is going to sit, our Python code, whatever language we are going to use. I recommend Python for this because it has got good libraries for networking. So our monitoring engine is going to be on Ubuntu VM. Fast API for backend, we're going to use Fast API, it's Python. Our PostgreSQL database, we are going to use PostgreSQL. It is just SQL, but for cloud PostgreSQL, we are going to use Supabase for that. For a cloud database, we don't have time for building all those MySQL stuffs. And also our NOC dashboard, all this, the software guys, all this, your entire code is going to sit in the Ubuntu server, which we are going to install inside the VM Workstation Pro. So our monitoring engine, our Python code, our backend API, our PostgreSQL database will be on the cloud, but the definitions will be on the server, on the Ubuntu server. Now the NOC, the dashboard, the front end is also going to sit inside the Ubuntu server, and email alerts or app alerts, they are going to be there. So any question, guys, on this architecture, what you don't understand or what you need or where you need clarity and everything before we move on here. Any question? Any question, guys? Any question? Or contribution or clarity? Nothing?
It's clear.
It's clear. Okay. Donald, anything?
Sure.
Any question from you, Donald? Is Donald with us?
Uh, so, am I audible? To
Yes,
start
yes,
with.
yes, you are.
All right, thank you very much. So I've gotten some of the technologies that you've just talked about, but I couldn't see clearly when you're talking about statement as like what the solution is.
What I was when I was talking
But I've
about what, Tim?
gotten about the problem statement, like what,
Oh, kusogoro, kumbuyo.
yeah, like nikumbuyo kwa yeah.
Okay. So I didn't talk. I didn't say the problem statement like exactly like at in problem statement. I was defining the entire problem and the entire architecture.
Okay.
I mean the entire requirement. So it wasn't like a problem statement as a written problem statement. No, where we are going to we are going to write that during the writing the proposal. But let me just describe the problem at hand clearly. A networking company hired networking guys to create a network. They created the entire network, configured everything, security and firewalls. Now it happened that they are hiring a lot of guys because the network is big and it is too huge. Let's take for example like per airport. Now that network they're using is huge, so they are hiring a lot of people, and also there is too much man. They're doing things manual. They need to check to go and check on the server what systems are down. They need to ping manually. They need to ping manually all devices to see which one is down. They need to analyze the system, each device, what resources they are using, how much resources they are using, computing power, and everything. Now they see that it is too much. We can't be doing things manually, pinging all devices and everything. We can't be doing them manually. So what they do is that they hire the software guys to build a software system that will be monitoring the systems automatically and in real time. The system will replace all the manual processes that happens, and will be able to do it uh, um, automatically. So more like automation, network automation. Yeah, I don't know if there is any other clarification you need.
I think I now have a picture of what's been talked about.
All right, that's great. That's good. That's great. So we'll be able to also meet and structure the problem and the like. So this is GNS3. This is GNS3. Networking guys, learn about it. Check it out. It's not hard to learn. If you've used Packet Tracer before, you can be able to use GNS3 and quite just fast and clear. So that's GNS3. This is VM Workstation Pro. Now VM Workstation Pro, this is GNS3 VM which are installed inside inside the VM Workstation Pro here. So they're able to communicate there. GNS3 and VM Workstation Pro. So that's the architecture that we are going to use. This architecture here. Understand it. When you understand the architecture, everything is going to be easy when we start connecting. We have Windows. Inside Windows, we have GNS3 client, and then inside also Windows, we have VM Workstation Pro. Inside VM Workstation Pro, we have GNS3 VM, and then we also have Ubuntu Server VM. Now, let's zoom in a little bit for the networking guys. Let's zoom in a little bit. For the software guys, let's zoom in a little bit. the architecture, we have got GNS3 VM here. This GNS3 VM is running routers and switches. Now, this is how everything will be happening. GNS3 VM inside a virtual machine is running routers and switches, real-time routers and switches. Here, Jamini Cisco Gulisa yaja, those iOS images. Mr. Teo sent me those images. I spoke to him that we need this for our project, but we need to buy them. So he sent me free iOS images that he uses. So they'll be running in GNS3 VM. Now, this monitoring engine here running on Ubuntu server. This is Ubuntu server. This whole thing is Ubuntu server. This one is VM, GNS3 VM. All of them running in a what? Virtual machine, which is VM Workstation Pro. Now this monitoring engine that we are going to build the backend here will be able to send requests to this router, to GNS3 VM, to these routers for what? They'll be able to send ISMP request, SNMP request, and syslogs to these routers. These routers will return what? Data to this engine. This engine will process those data and save in a database. Okay, save in a database. If there are any critical things, they'll be able to send a rate either to email or SMS, but we are going to build only an app where they'll be receiving alerts here if there are any critical things. So monitor engine processes the data, saves in the database. Is it critical? Yes. Send an alert that there is a critical thing in the network. Now, when sends in the database, we have fast backend API. We have got also the front end here. This front end here will send requests to this what? To this backend here, this backend, and then get data in the database, and then data is shown on the front end. That is the zoom-in architecture. So this entire architecture here, these guys here, these two are these. When we zoom them in, that is how everything will be operating. So network built here, routers configured, firewalls, and everything done by network engineers, guys. Once that is done, now as the software guys will build the backend, send requests to the routers. The network guys, they need to make sure that we are able to receive that data, whatever data we request. They need to make sure that we're able to receive. When we receive, send alerts. If it's not critical, save in the database. Backend gets the data through the fast API there. Okay. Now development tools. These are the tools that we are going to need. Let's make sure that we install them. Let's make sure that we install them as quick as possible. Today it's Monday. By Wednesday, let's make sure that we have the tools installed. They are not hard to install. Let's make sure that we install by Wednesday. So network modeling, the network guys, we are going to use Draw.io. Draw.io is the one that we are going to use for network modeling. So network modeling, this is just creating modeling a network for usage. Why is this thing going? Okay, let me just go back here. All right, so network.io is what we are going to use for modeling the network. Network simulation, we are going to use GNS3 client and GNS3 server. Spoken about it. Now server, we are going to use Linux based server, which is Ubuntu. We are going to install it in a VM, in a virtual machine server here. Now virtual environment, the virtual machine we are going to use is VM Workstation Pro. VM Workstation Pro used to be paid, but it was bought, so no need for paying now. For software modeling, we are going to use StarUML for UMLs and everything. We are going to use StarUML architectures and components, diagrams, and those other stuffs. We are going to use StarUML. So each of us, networking guys, take note of your of the things you need. Software guys, take note of the things you need. But to run the entire network on your machine, we need all these. So all of us, we need all these to run the entire systems. Excluding Draw.io, because will be used by network engineers when modeling. So we need GNS3, install it GNS3 client on Windows, install GNS this guy here, Workstation Pro, and then inside install GNS3 server, and then install Ubuntu also inside this guy here. Yeah. Languages, we are going to use Python for server and network communication, and for rules definition, we're going to use Python. Now we are also going to use React for front end. The dashboard, we're going to use React. We're going to use React Native for the mobile app for alerts. This one is going to be simple, only for alerts, to receive alerts in real time. When there is a device that is down, Kalila mobile app Kalila that the device is up, and then an alert is shown so that they are able to assign that, okay, check up a network. So now Supabase Postgre, we're going to use Supabase Postgre for the database and also for authentication. That is that. So we're done for the network monitoring system, guys. The entire description, the requirements, the systems that we need, and everything. Any question before we conclude and call it a night? Any question? Yes, Christopher.
No, I don't have a question. Everything is clear.
Okay, Daniel.
No, everything is just okay. Maybe for just to be more clear, there will be need to personally go through the whole document and, of course, look at something in more details.
Okay, wonderful. I'll be able to send the documents immediately we are done in the group. Okay. Joshua,
All right.
any question or any clarification?
No, sir, I'm good.
Okay, that's great. Donald, we are good?
Sure. We're together.
Okay, wonderful. All right. So having done that and said that, accountability we are done, network monitoring system we are done, and project this we are done. Okay. So once again, guys, just on the closing remarks, let's make sure that we work on this. Let's make sure that we are accountable, and let's make sure that we are not reminding each other. This is our course. This is our marks that we need. And okay, Donald. Yes, there is a question.
Sure. Since the whole lot of the project, like since it involves both like software developers, like process like integrations with networking concepts. Based on the document that you have, the technologies to use, like have they been like divided into like the networking aspect as well as those into like the software development aspect?
Okay. So if I've gotten your question clearly, you are asking that whether the tools that are required have been divided in a way that these are only used for networking guys and these are only used for software guys, is it?
Sure.
Okay. So yes, there are tools that have been divided for networking and only for software, but also there are others that we all need to share. So for example, StyleML only software guys, uh, Draw.io only networking guys. Now these three are the only things that we need, all of us. These three, GNS3 client and GNS3 server, we all need it. Now this is the reason why the software guys need this. This is only for networking guys, but why do software guys need it? Because GNS3 is going to start the network, GNS3 server is going to run it. Now the software that the software guys are going to build, it is going to require to listen on the network in real time. But where is the network? The network is on GNS3. So you need GNS3 in order for your software to listen for the network. No wonder you need GNS3. You need it not for building or what, but only you start the network that the networking guys have built. When you start it up, it's running. You start now testing your software or running your software and everything. Now, GNS3 is going to require VMware. This virtual machine is going to require VMware, and also we are going to require the Ubuntu server. It's also going to be installed on VMware. So these are the things we need, all of us. GNS3 client and GNS3 server, Ubuntu server, and also VM Workstation Pro. These are the things that we are going to need. Now, if there are going to be challenges installing this, let's communicate, and then we can be able to meet physically so that we go over the installation of these entire things, so that we make sure that each of us we have got working environment. In short, we meet so that we set up the development environment, all of them, so that we make sure that on our laptops things are just running okay as we are going to start building. Yeah, so those are the things that we need. Now, for languages, the networking guys, they don't need these languages. Them, it is only to build the network, and also to now it sounds like a little job. Trust me, it's involving. You need to build the entire network. It's involving. It's something people pay in thousands of money building a network. Let's say, for example, mupanga network yapa airport or yapa bank or yapa yamu industry. It's something that people pay in thousands of money just building a network. It's not going to be an easy job. It's going to be a huge network because we are following an industry standard grade network. So the software guys, you need these languages, and also Supabase and authentication, because you'll be building the software. And the networking guys, they're going to need network modeling tools, GNS3 client and GNS3 server. In order to build, they are going to need these, but we also need them only to run. Yeah, I don't know if I've answered your question or you need anywhere clarification anywhere. Okay, that's great. Anything also from anyone? Anything? Anything? We are cool? Okay. If we are cool, then we call it a night. Okay, anyone who wants to say anything, guys? Okay. Nizakamba tozi tikambeko something. Christopher, we'll start with Christopher. Say anything, Christopher.
I don't have much to say. I can say that we should do our best to work together. So that the project we can have good grades in this project. That's all.
That's great. Thank you, Christopher. And it's not only about good grades, but it's also about building a skill. If you see the entire project, it's going to help us build the skill and collaborate, network, and everything. Thank you very much, Christopher.
Yeah.
Joshua, it's you.
All right. Thank you so much. For me, I would just say it's a thank you to everyone, as well as to you for all the effort that you've put in. Like looking at the orientation, the presentation, it just shows how much investment you made in the project. So it's even an inspiration to all of us, seeing that you've elaborated everything. So we know that it's going to be a successful one if we just put in our best, as Christopher has said, working together, being accountable, and this will be a successful one and a good one. And to learning more from each one of you. Thank you so much. Yeah.
Thank you very much. Thank you. I appreciate. Okay, Daniel Nkoma, you're up.
Okay, for me, I don't have much to say. All I can say is that, or may I say, let me just express my gratitude, especially for the great works you've actually exhibited and the efforts you've made in bringing us and, of course, coordinating us to put us in one accord. So I feel, and I'm very hopeful that this is going to be a great team. And of course, we'll produce good results at the end of the year. So that's all I can say for now. We'll share more, I think, in the next session.
All right, thank you very much. I appreciate. All right, Donald, you are up.
Mm.
Sure. I equally have nothing much to say besides um, I'd like to say thank you very much, like, for the effort that you've put in, especially like concerning the research based on like the technologies to use. Um, I want to believe to say like it's not something that is easy, concerning the fact that obviously there are multiple technologies out there. You know, research takes a lot of work, and you did it anyways. Thank you very much.
Thank you. I appreciate, guys. Thank you very much. Now, this is inspiration. Have you seen Moses? Moses no come back or something, but just the fact that you have appreciated its inspiration also on my side to continue doing what you guys consider that is great work. I appreciate from all of you. Thank you very much. All right, guys. Have a good night, and those software guys, all the best. Writing your quiz on Thursday.
Yes.
Study well, and thank you very much, guys. Good night.
Yes.